Hello again. Now in this video we are going to further see the importance of freeze frame data. I have mentioned this word several times before. Now we will elaborately go into what is this freeze frame data and also what is meant by permanent diagnostic trouble code. In vehicle diagnosis and onboard diagnostics, two important concepts that help technicians identify and troubleshoot problems effectively or freeze frame data and permanent diagnostic trouble code. Okay, so what is meant by freeze frame data? Freeze frame data is snapshot of critical sensor and subsystem. Underline this word: snapshot of critical sensor and system data captured by vehicle's engine control unit at the moment a diagnostic trouble code is triggered and the malfunction indicator lamp is turned on. So the most important difference between DTC and freeze frame is DTC only denotes what is the trouble or where exactly is the trouble. But freeze frame data, it gives an elaborate picture about various engine conditions at the moment DTC was triggered. Okay, so it helps the purpose is to help the technicians understand the conditions under which the fault occurred. Underline this word carefully. Understand the conditions. What is the RPM? What is the engine temperature? What is the coolant temperature? What is the oil temperature? What is the oil pressure when the trigger was code? Okay, so that gives the technician a clear cut idea, a clear cut big picture about the circumstance under which the trouble code happened. And when it comes to useful in diagnostic intermittent issues, captures data that might not be available by the time a technician inspects the vehicle. The purpose of this is to capture the data and to ensure that data is available to the technician when he scans the vehicle. Now, we'll see what are the various typical types of data that is captured when as a part of the freeze frame. Depending on the manufacturer and DTC, freeze frame can include not all contain the same parameters, but understand this is not an exhaustive list or a common list. This is a very generic list. It depends on the severity and type of the DTC and the OEM implementation. So there are some variable factors like the OEM implementation also, but major parameters are engine RPM, vehicle speed, throttle position, engine load, coolant temperature, fuel trim, intake manifold pressure, battery voltage, oxygen sensor readings. So these things will give the technician a clear-cut idea what exactly led to the DTC. And this is also OBD2 regulated. This is a part of the OBD2 regulation. According to SAE J1979 and ISO 15031 standards, at least one frame must be stored when a DTC that triggers the mill is detected. All right. Now, this sentence is important. At least one frame must be stored. Understand, that's the reason I highlighted this. When a DTC that triggers the mill is detected. For example, let me give you one example, one use case. Suppose DTC says P0301. It shows that cylinder 1 misfire in the powertrain. Now, the freeze frame might show engine RPM is 2500, vehicle speed is 60 km per hour, coolant temperature is 85 degrees centigrade, and this helps the technician to know whether the engine was under normal operating conditions when the misfire occurred, not during warm up or idling. For example, if coolant temperature is somewhere between 55 degrees or 65 degrees, it only shows that engine was still warming up. And DTC misfire happened even before the engine coolant temperature reached an optimum temperature. So with like this or in this manner, a technician clearly understands, technician clearly infers whether what was the exact engine working condition when the DTC occurred. Now, what is meant by permanent diagnostic trouble code? The definition of permanent diagnostic trouble code is the permanent DTCs are codes stored in ECUs to indicate a malfunction that cannot be erased using a scan tool until the issue is verified to be resolved through vehicle's own internal self-test. Okay, so understand this highlighted portion that cannot be erased. Permanent diagnostic trouble codes cannot be erased using a scan tool until the issue is verified to be resolved. So one important thing is it cannot be erased, and only after the issue is verified to be resolved and through the vehicle own internal self test this can be removed or eliminated. Now next is the purpose. Ensures the emission related problems are truly fixed before clearing the codes. It prevents fraudulent code clearing. Example, clearing before the vehicle inspection to hide problems. So suppose somebody wants to hide the problem of a vehicle. They may have the fraudulent or dubious intention of clearing the code. That practice can be eliminated, or that can be mitigated with the help of permanent diagnostic trouble codes and aimed at emission control system integrity compliance as per US EPA and CARB standards. And when do permanent DTCs appear? When DTC triggers the mill. Okay, this is one important instance at which permanent DTCs appear, and ECU stores a permanent DTC along with the regular DTC and freeze frame. When they are cleared, only after the OBD monitored that detect the fault ran successfully. Okay, underline this, read this highlighted words very carefully. Only after OBD monitor that defected the fault run successfully, then permanent DTCs can be cleared. Example for a misfire code, the engine must complete a number of drive cycles without misfiring before the ECU automatically erases the permanent DTC. The use case example. Let's say the car has P040420 and as per this DTC, catalytic system efficiency is below threshold. The mill is on and permanent DTC is stored. The technician replaces the catalytic converter and clears the DTC. So only after the catalytic converter is replaced, then the DTC is cleared using the scan tool. Until and unless then, the DTC cannot be cleared. So now you understand the difference between ordinary DTC and permanent DTC. All right, hope so. However, the permanent DTC remains only if the car completes a successful catalyst monitor during the drive cycle. The permanent DTC is cleared by the ECU. Okay, you understand? So even with a scan tool, GTC cannot be cleared. It is only after the ECU verifies that catalytic converter is working properly, then the permanent DTC is cleared off. All right. So this is a summary table. We have freeze frame data. We have permanent DTCs. We have the purpose, stored when, cleared when, user clear, survives battery disconnect. So I request all of you to pause the video and as a to refresh yourself to recap all the data which I mentioned so far, please go through this table. You will get a clear cut idea. Now let's walk through how to interpret freeze frame data using real world example of common fault code P0171 system 2 lean bank 1. The fault code P017 system is 2 lean. All right. And the sample freeze data is engine RPM is only at 850 RPM. That means it is still at idling speed, and vehicle speed is 0 because it is idling. Coolant temperature is 75 degrees centigrade. That means engine is still warming up. Air intake temperature 30 degrees centigrade. Ambient air temperature. Short-term fuel trim plus 20 degrees. That means ECU is adding fuel aggressively. Long-term fuel trim is 15%. That means it is persistent lean condition. Throttle position 12%. That means there is slight throttle opening. It has not yet fully opened because throttle position is only showing 12%. And map sensor, manifold air pressure sensor is only 28 kPa. That means engine load also is very less. So these are all the various inferences from a freeze frame data. And what does this tell us? This clearly tells us that high fuel trims show the ECU is compensating for lean mixture by adding more fuel. Okay, and idle RPM and zero vehicle speed suggest the issue was detected while idling. and the coolant temperature indicates that engine was not fully warmed up, which can affect the fuel efficiency. Now it's a common IC engine knowledge that efficiency is at its best when the engine is fully warmed up. Now coming to the map and throttle position, they confirm the low load conditions. All right, so the likely cause is vacuum leak, maybe a cracked hose or intake manifold gasket, dirty or faulty mass airflow sensor. There's a good chance this is happening. Weakly fuel pump or clogged fuel filter, and a leaky exhaust near the upstream O2 sensor. Okay, so these are all the likely causes, and this is exactly how, by seeing the freeze frame data, a technician can infer where exactly the fault is or what are the likely causes. Okay, so the next step is inspect vacuum lines for leaks, clean or replace the manifold air fuel sensor, and next is check fuel pressure and delivery, or scan live data to confirm fuel trims under different conditions. Okay, so hope all of you got a clear cut idea the importance of freeze frame data and why and also the permanent DTC. Thank you.